Hey everybody, welcome back to Math Pastor. Hey, last video we talked about properties of exponents, the product property of powers and the quotient property of powers. Today we're going to explore what happens with negative exponents or exponents of zero. All right, hey, let's look first at what happens for the powers of 2. And we've talked about the powers of 2. It's just a doubling property. And when we look at powers of 2, 2 to the first power is 2, because anything to the first power is itself. 2 to the second power is just 2 times 2, or 4. And then 2 to the third power is 2 times 2 times 2, which is 8. So if we look at this pattern going up, it just doubles. It goes from 2 to 4 to 8, and you probably guessed the next one would be 16. Now, if we work this pattern backwards, well, going from 8 to 4 is dividing by 2. And going from 4 to 2 is dividing by 2. So going up multiplies, and going down divides. Now we can continue this pattern in either direction. So let's go ahead and continue this pattern down to see what happens when we have a zero exponent. So on the left, we go from 2 to the third to 2 to the second to 2 to the first power. The next one would be 2 to the 0 power. That's on the left side. On the right side, 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. So it looks like 2 to the 0 power, if this pattern continues, would be 1. But let's keep going. On the left side, taking 1 away from the exponent, it would be 2 to the negative 1 power. On the right side, well, 1 divided by 2 is just 1/2, 1 over 2. And then continue the pattern again. 2 to the negative 2 power on the left. Then divide 1/2 by 2. Half of a half is 1/4, which, keep in mind, 4 is 2 squared. So it appears that we got 1 over 2 to the first power when the exponent is negative 1, and 1 over 2 to the second power when the exponent is negative 2. Well, let's continue just to make sure. The next one on the left would be 2 to the negative 3 power. And on the right side, dividing by 2, well, what's 1/4 divided by 2? Same as, we could say the same thing by half of, what's half of 1/4? Well, half of 1/4 is 1/8. Well, look back to the top of this pattern. 2 to the third power is 8. 2 to the negative third power is 1 over 8. So it looks like when the exponent is negative, it is 1 over whatever the positive power would be. Hey, the same thing happens with any number. Here's the same property in the patterns with 3 as the base. 3 to the third power is 27. 3 to the second power is 9. 3 to the first power is 3. We continue this pattern going down. 3 to the 0 power is 1. 3 to the negative 1 power is 1/3. 3 to the negative 2 power is 1/9. Divide 1/3 by 3 and you get 1/9. And 3 to the third power is 1 over 27. So as you can see, with whether the base is 2 or 3 or any other number, we see two properties arise from this pattern. The first one is called the zero exponent property. And it says any number A, so it can be any number A raised to the 0 power is 1. That means 5 to the 0 power is 1. 10 to the 0 power is 1. 100 to the 0 power is 1. A billion to the 0 power is just 1. Anything to the 0 power is 1. The second property is called the negative exponent property. And the negative exponent property says if you have any number A raised to a negative exponent or a negative power represented by the number or the letter n, so A to the negative n is going to be equal to 1 over A to the positive n. So the negative exponent, get ready for this big mathy word here, the negative exponent reciprocates the power. Reciprocates just a fancy math word that says make it a fraction with 1 as the numerator. So 3 to the negative 3 power we saw was 1 over 3 to the positive 3, or 27. Now we can do this with a couple different numbers. We can do this with any number, actually. Any number. So pick a number. Well, I'm going to pick 5. 5 to the negative 2 power becomes 1 over 5 to the positive 2 power. Well, 5 to the second power is just 25. So 5 to the negative 2 equals 1 over 25. The second kind of problem you'd see in this section of a textbook would be write without a fraction bar. That means just undo what we just did in the first two examples. So we're going to see a term that has a fraction, a numerator and a denominator. And what we're going to do is we're going to take anything that's part of the denominator and bring it up to the top of the fraction, the numerator, and then write the exponent as negative. So here's an example. 3 over y squared. Well, 3 is the numerator, y squared is the denominator. If we want to bring the denominator back up top, all we have to do is make the exponent negative. So 3 over y to the second power becomes 3 times y to the negative 2 power, and there's no more fraction bar. And that's the second type of example. So anything down below can be brought back up top by making the exponent negative. All right, the final example is we want to use properties that we learned last video with negative and zero exponents. So remember, when we had a product property of powers, we added the exponents as long as the bases were the same. And if we had the quotient property of powers, we subtracted the exponents as long as the bases were the same. So we're going to look at a couple examples. First, let's look at this one. 3m to the 5th power times 5m to the negative 2 power. Remember from last video, just multiply the numbers. 3 times 5 is 15. And then if we have m to the 5th power and m to the negative 2 power, we're just going to add those exponents because the base is the same. They both have a base of m. So 5 plus negative 2 is really just 5 minus 2. So m to the 5th times m to the negative 2 power becomes m to the 3rd power. So 15m to the 3rd power is how this example works. Now, if we were left, once we combined those exponents, once we combined the exponents, if we were left with a negative exponent, we would want to kick it down below or reciprocate it like we did in the first couple examples. All right, one more example, and I'm going to pick a doozy here because I think we can all do it. That way, when we see a problem in our homework, we won't wig out. We have done something more challenging. So here it is. You ready? 12q to the 2nd power over 3q to the negative 8th power. All right, again, we're going to think about these in pieces. We're going to put the numbers off to the side and the q's off to the other side. So let's simplify this in parts. 12 divided by 3, that's easy, it's just 4. 12 divided by 3 is 4. So that reduces, or that simplifies, to be 4. All right, now let's look at the q's. Okay, we end up with q squared over q to the negative 8th power. Well, before, when we had a negative exponent, we kicked it to the other part of the fraction. So when we saw a negative exponent in the numerator, we kicked it down to the denominator. The same is true going backwards. If we see a negative exponent in the denominator, it's going to kick that variable with the power back up top. So q to the 2nd power over q to the negative 8th power becomes just q squared times q to the 8th. Now we know our power property. So we are going to add these terms. 2 plus 8 is 10. Excuse me. So we have 4q to the 10th power. We can also use the quotient property of powers here. Check this out. Hey, look, we have q squared over q to the negative 8th power. And we know that when we divide powers that have the same base, we subtract the exponent. So 2 minus negative 8 is just 10. So this whole thing becomes just q to the 10th power. So you can do it either way. You don't have to do it both ways. Whichever way makes more sense to you or you think is easier, go ahead and use that. But let's look at this whole thing one more time. 12q to the 2nd power over 3q to the negative 8th power all simplifies down to be 4q to the 10th power. Hey, I think you're probably ready to tackle any property or problem you see in your homework. If you get stuck on one, move on to a next one or move away from it for a little bit and then come back to it with fresh eyes. That's my advice for today. All right, have an awesome day. Good luck with your homework. See you next time.